Okay, we have already recalled about sigma and pi bonds and also about sp3, sp2, and sp hybridization. Now it's time for us to learn about isomerism. This is the learning outcomes. So there are two types of isomerisms that we should learn, structural and stereoisomerism. Okay, now I'd like you to pay attention to this picture. Okay, we will start from the definition. What is structural isomerism? I like to take notes regarding this and this, yeah, since it is appear in past paper questions. Okay, if you need to make the definitions with the good words, please write structure formula. Yeah, structural isomerism, that means molecules with same molecular formula. Okay, molecules with same molecular formula, but different structural formula. Okay, they have same molecular formula, but different structural formula. That's structural isomerism. And what is stereoisomerism? Molecules with same molecular and structural formula. Molecules, yeah, with same molecular and structural formula, but different arrangements of atoms in space. Yeah, different arrangements of atoms in space. Or different arrangements in 3D space. Yeah, you can also say like that. I repeat once again, stereoisomerisms are molecules with same molecular and structural formula, but different arrangements of atoms in space. Okay. So done, right, with the definition? Okay, now let's see the classification of isomerism. Structural isomerisms can be divided into three types of isomerism, which is chain isomerism, position, and functional group isomerism. Later, I will give you explanation one by one about this chain, position, and functional group. So please remember that chain, functional group, and positions are classification of structural isomerism. While in stereoisomerisms, there are geometrical isomerisms or cis-trans isomerism or easy. Yeah, you can see here, easy isomerism. And then the second one is optical isomerism. Okay, please take notes regarding this. Okay. Let's try to answer this. Just write in your notes. Okay, let's answer this. Explain the meaning the term structural isomerism. 2 points here. First one, if you state that the molecules with same molecular formula but different structural formula. This is one, this is one. Stereo. Molecules with same molecular and structural formula but different arrangement of atom in space. Okay, molecules with same molecular and structural formula 1 point, different arrangements of atoms in space 1 more point. Okay, so if you just state molecules with same molecular formula, you just got 1 point. So please remember. Okay, get it? Same molecular formula, that means, for example, if I have C3H6O, yeah, let's say like this. So this molecule have C3H6O, both have same molecular formula, but later on they differ in structural or different arrangements of atoms in space. Yeah. So once again, that this is the mean of same molecular formula. Okay, I will divide the video into 2 sections. Okay, the first section is cover about structural isomerism, and then at the next video, we will cover about stereoisomerism. Okay. Okay. Once again, in structural isomerisms, there are chain, position, and functional group isomerism. Okay, what is chain isomerism? They differ of their carbon skeleton, how the carbon connected to another carbon. Okay, they have different carbon chain. The chain isomerism, the chain isomers will have the same chemical properties, but slightly different physical properties. Because if the carbon has a straight chain, yeah, they will pack more regular, so the boiling point will be higher compared than the branch one. Okay, for example, butane and methylpropene. You can see that they have the same molecular formula, which is butane. This is C4H10, right? Methylpropane also C4H10. So please remember, isomers are structural isomers are molecules with same molecular formula, but they different in the structural formula. So in this case of how the carbon connected to another carbon, this is straight chain, this is branch. Once again, the chemical properties will be same, yeah, since they have the same functional groups. So this is alkene, but the physical properties will be different. Yeah, the boiling point of butane is higher compared to the methylpropene. Okay, draw the discrete formula and give names for isomers of C5H12. Okay, let's discuss about this. Okay, first thing that you should do is what is functional group inside this molecule. Okay, it is alkene since CnH2n plus 2, alkene, right? C5H12. So let's start with the straight line, the straight chain, 1, 2, 3, 4, 5. Okay, every time you make the isomers, I'd like you to give name, because if not, yeah, you will make mistakes by yeah, make the same structures, yeah. But if you try to naming it, yeah, you can see that whether you repeat the same structure or not. Okay. Okay, for this is the first isomer. What's the name for this? Okay, this is N-pentane. Yeah, normal pentane, or you can see pentane. Yeah, you can write pentane. Okay, number 2. If I done with the straight chain, I will make branch. Okay, so now I have 4 longest chain with 1 C as branch. Please remember that the branch position cannot be at the first C, because if I draw like this, yeah, carbon at the first C, it will become the longest chain again. So please remember that branch cannot at the first or at the end, yeah, at the end carbon. So the branch should be start at the second carbon like this. So what's the name? Yes, it is 2-methyl butane. And then if you think you can move this to the third carbon, then if you try to naming this would be 2-methyl butane as well. Because now you should numbering from this, from left, to make branes have the lowest number, right? So actually this same with this, even you already moved this to this, right? So that's why I told you that it is very important for you to give name, yeah, to see that whether you repeat the same structure. So this is wrong. So there is no other possibility, right, for 4 straight chain. Now we will remove one more C to make 3 straight chain like this. So 2 more C's for branch. Once again, it cannot at the first or at the end position. So should be here, right? What's the name? It is 2,2-dimethyl propane. Okay, 2,2-dimethyl propane. And what another possibility? How about this? Means I want to make ethyl as the branch. Can I? How about if I give name to ethyl propane? Is it the fourth isomer? Hold on. We should check. Yeah, you should check by try to find the longest chain first. If you throw like this, then this will be the longest chain. Right? Not 3, but 4. Okay, and how about the name? I should numbering from this. 1, 2, 3, 4. So this is 2-methyl butane. So repeat the second isomer, right? 2-methyl butane. So this is not 2-ethylpropane, but 2-methyl butane. So this is wrong. So how many isomers for pentane? Only 3, yeah? This is we call a structural formula, the chain isomerism, since they differ only in the chain-chain connection, in the carbon-carbon connection. Okay, everyone, how if I told you to make the isomers of C6? It's 14. Okay, once again, please try to make the straight chain 1, 2, 3, 4, 5, 6. Okay, start from this, naming this hexane. Okay, and hexane. After that, remove 1. Yeah, remove 1 C, and then try to make this C as the side chain or as the branch. So now I will remove 1. So the longest chain only 5 now. 5. 1 as the branch, I will put at the second C. Okay, so this is 2-methyl pentane. How if I move the branch to the third C? Can we? Yes, we can. Yeah, since the name differ, they different compound. They are different compound. So this is 2-methyl pentane, while this is 3-methyl pentane. Okay, so like this, just continue. How if I move this to the fourth C? If I move this to the fourth C, it will become 2-methyl pentane again, because now numbering at the from the left side, right? So that's why isomer and naming has a very great connectivity. Yeah, so every time you make isomer, please give name. Make isomer, please give name. Yeah, so you can see that you not make mistakes by repeat to make the same structure. Okay, this is not done yet. Yeah, you can continue until you cannot find another isomer. Okay, let's continue to the second structural isomerism. It is position. Yeah, the first one is chain. Okay, number 2 is position isomerism. Okay, in position, it is the position of the functional group that varies in its isomer. So let's say I have compound with chemical formula C3H6Br2. Okay, I can locate it Br. Okay, at the first on the second carbon. This is 1,2 dibromo propane. Okay, and then I can move it one Br to the third C. This and this is 1 and this 3. So the name would be 1,3 dibromopropane, right? Different compound. How about if I move to the first C's, 1 and 1, yeah? 1,1 dibromopropane, it can be, yeah? And then second, 2,2 dibromopropane. And no other possibility. So there are 4 possible isomers. Once again, the the carbon-carbon chain is still same. Propane, right? CCC. There is no brains, there is no, yeah. So this is not chain isomerism, but position isomerism. Once again, since the position of functional groups differ. Okay, so we can find position isomerism in halogenoalkene or in alcohol. You can see it here. Okay, they all have the same chain, carbon-carbon chain, straight chain. Yeah, you can see here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So same chain, yeah, but they differ in the position of functional group. In the first, yeah, let's say this is the first, yeah, the first isomer. Yeah, let's say this is the first isomer. The name of this compound is pentane triol, yeah, pentane triol. And this is pentane 2-ol. And this is pentane 1-ol. Okay, they differ only in the position of OH group. It can be at the first C, the second, or the third. So this is called as position isomerism. They differ in the position of functional group. Another compound that shows the position isomerism is alkenes or alkynes. Yeah, alkenes or alkynes. So if the position of double bond, yeah, can be moved, yeah, it arises the position isomerism. So this is but 1 in, and this is but 2 in. You can see that the position isomer of the double bond shift, yeah, raised to but 2 in, and no other possibility. The chain still same, straight, 1, 2, 3, 4, 1, 2, 3, 4. Yeah. So this is position isomerism. Okay. So what is position? They differ in the how the functional groups connected to the C. Yeah. The position of functional group can be moved. Yeah, can be changed. That's position isomerism. Okay, let's try this. Okay, this is CN, H, 2N plus 2O. Okay, this is the molecular formula for alcohol or ether, yeah. But since the carbon only 3, so there will be no position isomerism of ether. So only alcohol. Okay, 3 C's. So 1, 2, 3 with OH group here. Give you propane 1-ol. and you can move it to here, propane 2O. No other possibility, right? So the display formula and name the isomer would be propane 1O and propane 2O. Okay, since this question asks about display formula, you should open all bonds, yeah? Yeah, H complete with H. Yeah, something like that. Okay, we have learned about chain isomerism, position isomerism. Now it's our turn to learn about functional group isomerism. Okay, in functional group for isomerism, there are different functional group present. For example, like I told you, C3H8O, we can draw alcohol or ether. Okay, these two isomers have different functional groups and so different chemical properties. Okay, you should understand which functional group have the same molecular formula. Yeah, it is alcohol with ether. Yeah, alcohol with ether. Cn H2n plus 2O. Usually like this. So C2H6O, a molecule that has a molecular formula C2H6O, can be drawn as alcohol. It is ethanol. Yeah, C2H6O, right? Or it can be dimethyl ether. Okay, or methoxymethane. Yeah, you can see that they have the same molecular formula C2H6O. So alcohol with ether, functional group isomerism. Next is aldehyde ketone, CnH2NO. Okay, in this example, propanol with propanone. Okay, you can see that propanol has 3 C's. How many each? 6, 1O, C3H6O. How about propanol? C3H6O. Okay, so same molecular formula, but different functional group. Functional group isomerism. So alcohol with ether, aldehyde with ketone. One more functional group isomerism is carboxylic acid and ester. C2H4O2, right? Methyl ethanoic, C2, C3. Oh, this is not the isomer of this, since the molecular formula different, right? C3H6O2. So these are not functional group isomerism. So the functional group isomerism for ethanoic acid should be, how about the ester? Yeah, HCOOC, H3, right? Methyl methanoid, C2H4O2. Okay, this is the isomers of ethanoic acid is methyl methanoid. Yeah, they have the same molecular formula C2H4O2 but different functional group, CnH2NO2. This is the general formula for carboxylic acid and ester. So what's the acid for methyl methanoid? What's the isomer for this? Yeah, 3 Cs. So it would be like this, right? Propanoic acid. Yeah. So there are 3 functional group isomerism: alcohol and aldehyde, alcohol and ether, aldehyde and ketone. The third is carboxylic acid and ester. C3H6O that are aldehyde and it is ketone. Please try. Okay, C3H6O as aldehyde would be like this. A ketone would be like this. Yeah, okay, easy because small molecular formula. How about this? Draw and name all the structural isomers of C3H3H3Cl5. Okay, this is the last question. After that, we will move to the stereoisomerism in the next video. Okay, please try this. Please pause the video. Okay, let's discuss how many isomers that you found. I found 5. Okay, you found less than 5? Okay, let's draw the structure. C3S3Cl5. I like to draw like this. The position of Cl. There are 5 Cl's here. Let's say I put here at the first C. Maximum, right? 3 Cl. And then go here, 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 and here. So the name would be 111, 22, pentachloro, longest chain 3-cis propane. Okay, this is the first isomer. Okay, next, for the second isomer. Still Cl, Cl, Cl. I can move one Cl for at the second cis to the third C. Okay, I shift this to here. Okay, since it is Cl, it cannot be the longest chain. So it is okay for us to put Cl at the end of the chain. Yeah. I move here. So the name would be 111, 23, pentachloropropane. Okay. The other possibilities, number 3, 11133. Yeah, still same, pentachloropropane. Number 4, 11223. Yeah, 11223. And the 5th, 11233. Okay, if you can find all the 5 isomers without help, you are good. Yeah, in isomerism theory. Okay, so we are done with structural isomerism and hybridization. Thank you for your attention and see you again. Bye-bye.